you talk a little bit more about what's the uniqueness, highlighting just that aspect, please? Thank you.
Yeah, thank you. So the uniqueness is majorly here that all this comes together, that you have a bunch of tools which you don't find in such collection anywhere else, where you can go from model-based bin picking, so you know about your model. We even have different approaches, at least 3 different major approaches for model-based bin picking, which is a classic one, which we already solved many times in industry. We have a learning-based approach, and we have an AI-based approach without learning, so you can choose from a big selection of solutions, and one of them always works with your parts. And on top of this, we even have model-free approaches that can work with our system. Yeah, we are concerned about the whole procedure. So this is also not standard in every bin picking solution, that we are concerned with the gripping part, with the collision freeness of part, of optimization of the whole system. And in the end, the physics-based simulation that we make use of is very, very useful, because we can draw so many advantages from it, from forecast before you set up a system down to quickly setting up new systems or new parts with your existing system, so that you are super flexible in your production. We call it automation of automation, so that automation systems automate themselves. And this is what we do here.
Oh, that's just fantastic. Thank you, Dr. Richard. And maybe this is for Daniel. We would love to know, how quickly can we set up both the simulation environment and also the actual robots themselves? What timeframes are we talking about?
Yes, good question. So the simulation environment we saw here, I mean, we are now not talking about setting up a simulation, but setting up the system is capable of the simulation. To be precise here, we need round about a week. So we have to probably come to your place, check the hardware which is available, analyze it, and we have to install different things. We have to install the back end, the front end, which is all simple to use and Docker based, like the front end we saw provided by Wetzling. But in the end, we have to run a few tests and see if they communicate to each other. And this includes setting up of the hardware as well. Once we have the simulation working, and we want to use the results in the real bin picking cell, it of course depends on where we start. Do we start completely from scratch? Then it takes quite a long time. But assume we have a basic cell already available, installation of the robot, installing everything, up to 2 weeks is realistic. If you want to do some changes in the cell, like using a new camera with the approach, or just changing the robot, we're talking probably around about a week. If you have a complete runnable system, you just want to install our software, we are around about 1 or 2 days. And when you just want to, what Richard already says, you have a complete system, our software is installed, and you just have a new object you want to pick up, that's more or less immediately. So we are here talking about hours. So it's like upload, it's immediately it's uploaded, and then run a test if it really works, maybe fine tune 1 or 2 things, and then it's done.
That's very, very impressive timelines for such cutting edge technology. Thank you so much, Daniel. Richard, I have a question for you now. There might be customers out there that don't have the robo systems, that they haven't chosen the robotic provider. Is Fraunhofer IPA able to help such customers?
Yeah, absolutely. Yes, we are also advising with our experience in automation systems. So you come to us. If you have no clue about how you want to automate, you just come to us with your task. You tell us what are the boundary conditions, what you want to achieve, and we can give you suggestions for useful and optimal setups for your current problem. And we also team up with systems integrators in the end, because we are not a standard company as said. So in the end, we will always work with a systems integrator, either of your choice, or we propose some that will be capable of setting up the right robot cell at your place with all our fantastic software in operation.
Great flexibility and agility. Thank you, Dr. Richard. A few more questions. How are such systems trained? This has come up on LinkedIn Live. How are such systems trained, and how big are the sample data sets?
The sample data set are, I'm not really sure what kind of data set. So when we do a simulation, we saving the results in CSV format, so it doesn't really take up a lot of space. Our project we are creating to be used in BP3 highly depends, and that's the important thing, of the size of the meshes. If we have large meshes, then the meshes in the simulation will be large as well. Currently, this complete setup and the one project, the one I just showed you, is around about 30 megabyte, nothing. And the network, there's more important, the GPU consumption, which I already explained, is less than you can fit the neural networks in an 8 gigabyte GPU.
That's great. Thank you, Daniel. And a couple more questions and we'll wind up. One is, how do you manage with very tightly packed objects in a bin? And
Yes.
how does the system work with transparent objects? Does it work well even with transparent objects?
Both really good questions, frequently asked questions. I would answer both of them. So first, about the tight packages in a bin. This is generally always a problem. We can, if it is physical possible, we can grasp it. But the point here is to find out, is it possible? Is your package too dense? Can you even grasp the object, and how empty you will get the bin? And this is what we can handle them. And the complete reason why we do it is to find out how well it will perform, or what hardware changes you have to do so it works better. That's for the packet objects. Talking about transparent object, that's a big thing. First of all, most of the time it depends on the computer vision system you're using, not detection software behind it. We can do a lot of things with software. We are working on it on research projects, and we have ongoing projects about this thing. But this is mainly a task for the 3D camera. We are working with state-of-the-art 3D cameras like Civet. Fully transparent objects are not visible. That's why they're fully transparent, that's for sure. But if they are semi-transparent and we have a good camera, we can work with them. Just as additional information, we are working here with 3D data. We are working with RGB images and depth images, which leads to a way more robust system overall.
Thank you.